Hey everybody. So as a closure for today's worksheet, or lesson, sorry, we're going to be talking about 312. 312 is the problem we're going to be doing. Okay? And in 312, we are asked to extend John's tree. So if you could, really fast, if you don't already have it, can you find that original table? 3, 4, 5. Okay. Okay. Hopefully you drew this. If you did not draw it, pause the video now and go draw this in your book. This whole table you see right here. Go draw that in your book. Okay, hopefully you're back because you paused the video and you've drawn this in your book. We are asked to extend our table to year 6 and then to work backwards in year 2, 1, and 0. Okay, this is the same idea as the patterns you worked with in 3.1.1. We are just going to extend it in numbers this time. So first things first, we'd have to identify, and hopefully you've done this already, how much is being added each year. So 17 to 21, what's being added? Hopefully you figured out that it's about 4, okay? 21 to 25 is still 4. That's enough to establish a pattern. So if we go one more year out, year 6 is going to be what? 25 plus 4 is 29, okay? Now we have to work backwards, right? If I added 4 forwards, what do I need to do backwards? Let me let you answer a question on Edpuzzle. Okay, hopefully you said I need to subtract 4, right? If going forward was plus 4, backwards is subtract 4. I have 17, so that meant that year 2 was at 13 feet. Okay, subtract 4 again. Year 1 is at 9 feet. One more time, subtract 4 for me, and that means that year 0, this tree was 5 feet tall. Now you may be thinking, that makes no sense. At 0 years, how is this tree only 5 feet tall? Remember, trees are planted as saplings, which means that they're a teeny tiny version of the tree, okay? And that allows them to grow. They're not planted from seeds, they're planted from tiny versions of their tree, okay? So our tree started out at 5 feet tall. Now, if you haven't done this already, we're going to write a rule using the same principles that we did yesterday, writing our rules. And hopefully in class, by the time you've done this lesson, we've played what's called a silent board game. If you haven't, then pay attention right now. You're going to compare your rule to mine. So, first thing that I ask you guys to do is to look at 0. Always look at 0. Okay, let's use a different pen color for this. 0 is your starting point, okay? I don't know why we call it B, but we just do. 0 is your starting point, okay? So whatever 0 is where you start. So start. That's where we start, okay? And then our growth is how much? How much am I adding each year? How tall does it grow? It grows about 4 feet every year, so our growth is 4, okay? Now, I'm repeatedly adding. Repeated addition is otherwise known as multiplication, right? So, a lot of people say that the rule should be x plus 4. Makes sense, right? Because I'm adding 4 each time. However, that only works if I am doing this one step at a time, right? Doesn't work if I'm not. If I want to do multiple steps at a time, I have to do that repeated addition, this multiplication idea. So I'm going to take x plus 4, and instead of x plus 4, cross that out, we're going to do 4 times x. That is multiplication, aka repeated addition of the number 4. Okay? Now, I don't just start with 4. If that was the case, then if I put 0 in for x here, year 0 should be 0, right? Year 1 should be 4, because 4 times 1 is 4. Year 2 should be 8, because 4 times 2 is 8, right? But that's not the case. what do I start with? I start with 5. So I have to say plus 5. Okay, as always, when you have your rule, you need to go back and check it. Make sure it's correct. So 2, if I put 2 in here, I now have 4 times 2 plus 5, right? That's 8 plus 5, which gives me 13. That's correct. I highly recommend you test your rule on at least 2, so let's choose one more. Let's do 6. 6 is a nice big one. So 4 times 6 plus 5. 4 times 6 is 24. Plus 5 equals 29. Ding, ding, ding. Okay, this rule is correct. And that's what we do. Now, at the very end, I'm going to let you guys do this on your own as a question. I want you to take this rule we just came up with, and I want you to apply it. What happens when the year, aka x, equals 50? You've already taken a guess at this, but now I want you to take your rule and I want you to confirm. What happens at year 50? Okay. You're going to answer a question on that. And that's the end of the video. If you have any questions, please let me know. If you were not in class while you were doing this lesson, then message me on Teams. I will be available all day for you. If you're in class, I am also available for you. So just ask me. And have a good day, everybody. Thanks for completing the lesson.